probably fractions, and we're not going to choose negatives if we don't have to, and we're not going to choose big numbers because we have to graph all of these, so we're not going to choose those things. We're typically going to choose about the same numbers, okay? But technically speaking, we could all have different answers because there are an infinite number of solutions, okay, an infinite number. I'm going to emphasize again, as I did with the intercepts the other day, that as much work or as little work as you need to show, that is your decision, okay? I'm going to work it all out again like I did with the intercepts. If you are really good at solving, you may not need to show as much work or maybe any work. So that's going to be an individual choice again, okay? I'm going to do all the math today though. I'm going to show it all and write it all, okay? So I go to make my table. And again, as I started out saying, I like to choose 1, 2, and 3. If one of those doesn't work, I'll erase it and put a different one, but I like to choose easy numbers. And it doesn't matter what you choose, and it doesn't matter for which variable you choose it for. I like those because they're easy. So it's kind of like doing the zeros, okay? Because you're going to plug these numbers in and you're going to work it out. So I'm going to plug 1 in for x. So I'm going to have 1 plus y equals 3. And your solving skills, once again, come into play. If solving is something you struggle with, you've got to make sure you're using some seminar time for extra help, okay? I'm going to solve these like I'm assuming you all solved very well, okay? If that wasn't the case, then you're going to need extra help. Okay, so on this one now, to get y alone, I'm going to subtract 1, and y is 2. So when I substituted 1 for x, I go to my table, I got a 2 for the y. There's my first ordered pair. So now I'll plug in 2. X is 2. So 2 plus y equals 3. Get your y alone, subtract the 2, and y equals 1. So when I plugged in 2, I got 1 for y. And I plug in 3. So 3 plus y equals 3. Get the y alone by subtracting 3, and I get 0, but I got to have 3 numbers that aren't intercepts. That's an intercept because I got a 0. So I got to pick another one. So I'm just going to go with 4. And you can leave that one there. You can erase it. I don't care. So 4 plus y equals 3. Get your y alone by subtracting 4. And y equals a negative 1. I only need 3. If you get an intercept, you can leave it or you can erase it and just put another one. Alright, so these all have formed ordered pairs that work in this equation. Now there are many, 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 many more. So yours might be different, but your line should look exactly like my line. Okay? So I'm going to go plot these points now. The first one is 1, 2. 2, 1. I'll go ahead and plot my 3, 0. And 4, negative 1. When you connect these points, you should get a straight line. If you don't get a straight line, then you'll know you're wrong. You'll know something's wrong. Because if they don't form a line, one of the ordered pairs is not correct. Or more than one. Oops, not a good line. And I draw my line. Yes?
So they have to be in some kind of order, like 1, 2, 3, or can we
No,
do like
do whatever
6?
you want. Do whatever you want. Just remember you have to graph it. So when you use bigger numbers, sometimes you get bigger numbers, not always, but just be careful of that. That's all. Yeah, you can pick whatever you want. Like I could have put, 5 negative 4 and 7.
You still would have got.
You still would have got the same line. Your points would have been in different places, but you're going to get the same line.
It's crazy.
Because there are lots of things that add together that give you 3. You know, 7 and negative 4, 10 and negative 7, negative 17 and 20. Lots of things that can give you that. Some other questions? The process is going to be the same on all these. The thing that's going to change is the algebra in the solving. That's what's going to be different from question to question. Okay? And that's where the mistakes could come in, obviously. Okay, so we're making a table. So x, y, I'm going to go with 1, 2, and 3 again. I like it because they're small numbers. So I'll start with my 1. So 2 times 1 minus y equals 2. I can already see that's going to give me 0. I'm going to finish working it so you can see it. I'm solving, so to get that y by itself, I have to subtract 2. And there's my 0. So I'm going to go up and, just to make it even simpler, I'm going to change it to a negative 1. Then I don't even have to change that much of my math. So I'm going to make it a negative 1 instead of a positive 1. So when I multiply, 2 times negative 1 is negative 2. Then to get that y by itself, I'm going to add 2 because it's a minus. So negative y equals positive 4. And I have to make the y positive, so I'm going to divide by negative 1. And y is a negative 4. All that solving stuff. So let's put in 2. 2 times 2 minus y equals 2. Yes?
Why did you divide by negative 1?
Because y is negative here, and you want your answer to say y equals a positive y. So to make it positive, you divide by negative. So negative divided by negative will make it positive.
Okay.
Just negative 1.
Uh-huh. Yes?
So you always want y to equal
Do I want y to be positive. It doesn't have to equal a positive number. I want my y to be positive, yes. So we're trying to find out what does y equal, not what does negative y equal. We want to know what y equals. Okay, so we plug in, did I put that in my chart? Yeah. So I plug in 2. So 2 times 2 is 4 minus y equals 2. Get your y alone by subtracting 4. So negative y equals negative 2. And divide by negative 1 to make y positive. And I get a positive 2. And I fill that in my table. Then I fill in 3. 2 times 3 minus y equals 2. 2 times 3 is 6 minus y equals 2. Get the y alone, so get rid of positive 6, so subtract 6. Negative y equals negative 4. Make y positive by dividing by negative 1. So y is a positive 4. All those solving things back from September that we're using over and over and over. You'll notice in any particular problem, like I did the same math steps on all three of those. Because it's set up the same way. Okay, I had to multiply, I added or subtracted, I divided by -1. Okay? Okay, so let's graph -1, -4, 2, 2, and 3, 4. And again, all of your points should be in a line, and if they're not, it's possible you just plotted the point wrong, so check that first. But if you're sure you plotted the point correct, then it's in your table. Okay, question on that one. All right, next question. Again, same process, different algebra. I'm going with 1, 2, and 3 again. And remember, you could choose them. Oops, forgot my 3 there. You could choose them for y also. I typically choose them for x. So I put my 1 in for x. So 2y equals 8 minus 3. 2y equals 5. Divide by 2. And I get 5 over 2, or 2.5. And I don't care how you leave it. I like fractions myself, so I would leave it as a fraction, but decimals are fine. Decimals are better for graphing, I guess. Now I plug in 2, so 2y equals 8 minus 3 times 2. 2y equals 8 minus 6. 8 minus 6 is 2. And divide by 2. And y is 1. And then my last one, my 3. 2y equals 8 minus 9. 8 minus 9 is negative 1. Divide by 2 and you have a negative 1/2 or negative 0.5. Sure.
Whenever we have a fraction, could we just put it like in between the lines? Like it doesn't matter if it's 2/3 or 1/3.
Just be careful where, because sometimes it won't look like a line then. Okay, so we have 1, 2.5. Two, 1. And 3, negative 0.5. Okay, question on that one. This is an example where I would not